Good day, sir. My name is Merjovi Cuarteros, and today I'm going to present about the RSA online calculator. How do I decode an RSA message? To decrypt a ciphertext C using an RSA public key, we simply compute the plaintext M as M equals D mod N. Note that both RSA encryption and RSA decryption involve a modular exponentiation, and so we would be well advised to use the repeated squares algorithm if we want to make these processes reasonably efficient. How to solve RSA algorithm problems? RSA algorithm is an asymmetric cryptography algorithm, which means there should be two keys involved while communicating, i.e. public key and private key. There are simple steps to solve problems on the RSA algorithm. You will have to go through the following steps to work on RSA algorithm. Step 1. Generate the RSA modulus. The initial procedure begins with selection of two prime numbers, namely P and Q, and then calculating their product N as shown N equals PQ. Step 2. Derive number E. Consider number E as a derived number which should be greater than 1 and less than P less equals 1 and Q1. The primary condition will be that there should be no common factor of P1 and Q1 except 1. Step 3. Public key. The specified pair of numbers N and E forms the RSA public key, and it is made public. Step 4. Private key D is calculated from the numbers P, Q, and E. The mathematical relationship between the number is follows: ED equals 1 mod P1 and Q1. Encryption formula. Consider a sender who sends the plaintext message to someone whose public key is NE. To encrypt the plaintext message in the given scenario, use the following syntax: C equals PE mod N. Decryption formula. The decryption process is very straightforward and includes analytics for calculation in a systematic approach. Considering receiver C has the private key D, the result modulus will be calculated as plaintext CD mod E and encryption. RSA algorithm example. Choose P equals 3 and Q equals 11. Compute N equals PQ equals 3, 11 equals 33. Compute N equals P1 and Q1 equals 2, 10 equals 20. Choose such that 1, Pn and E and N are coprime, let E equals 7. Compute a value for D such that DE equals 1. One solution is D equals 3, 37%, 20 equals 1. Public key is EN equals 7 and 33. Private key is DN equals 3 and 33. The encryption of M equals 2 is C 27%, 33 equals 29. The decryption of C equals 29 is M equals 293%, 33 equals 2. What is elliptic curve cryptography? Elliptic curve cryptography, or ECC, is a key-based technique for encrypting data. ECC focuses on pairs of public and private keys for decryption and encryption of the web traffic. ECC is frequently discussed in the context of derivatives. So elliptic curves are the set of points that are obtained as a result of solving elliptic functions over a predefined space. I guess they didn't want to come up with a whole new name for this, so they named them elliptic curves. How does elliptic curve cryptography work? Based on the values given to A and B, this will determine the shape of the curve. Elliptical curve cryptography uses these curves over the finite fields to create a secret that only the private key holder is able to unlock. An elliptic curve for current ECC purposes is a plane curve over a finite field which is made up of the points satisfying the equation y2 equals x3 plus ax plus b. In this elliptic curve cryptography example, any point on the curve can be mirrored over the x-axis and the curve will stay the same. Continuing from point C, we can draw a line through from point A to point C which intersects with another part of the curve, point D. This point is also reflected to the other side of the x-axis, and this process continues until an endpoint is defined. Each intersection point is defined in terms of a dot. In the example below, the intersection points will be described as A dot A equals B, A dot B equals C, A dot C equals D, and A dot D equals E. The number of the intersection point isn't unknown to those without the private key, thus making it very difficult to recreate the number of times the equation was dotted. Thank you.